As we know, and in one of my previous videos on the logic behind an ANOVA, that was a handwritten video, okay? The null hypothesis associated with an ANOVA is that all the averages, okay, all the mean values across all the groups, okay, that each group's mean value is equal to each other group's mean value. In other words, that there's no difference across any of the mean values for any of the groups or any of the levels of the independent variable. Okay, that's the null hypothesis. And when we're doing an ANOVA, we do an ANOVA at a particular significance level. Now, we can do corrections for the increase in the number of categories associated with our independent variable. In particular, we could have a look at some sort of Bonferroni correction, okay? Which is we take the significance level of our test and we divide it by the number of groups. In this case, 0.05 divided by 3 would give us a new significance level associated with this particular ANOVA. But let's just assume our significance is at 0.05. Okay, so we will reject the null hypothesis if the p-value is less than 0.05. And what you can actually see here in relation to this ANOVA output is that the significance of the test is 0.000. Actually, let me double click on this. Just going to double click on this table. Just get rid of that there. If I just hover over this here, you can actually see, wow, it's 6.553 by 10 to the minus 172. So like it's effectively 0, yeah, which is less than 0.05. And as such, we would reject the null hypothesis in favor of the alternative. Now, what's the alternative telling us? The alternative is telling us that at least one possible pairings of our groups, that could be managers against custodians, managers against clerical officers, or even the custodial officers against the clerical officers, that at least one possible pairing, or all of them, have different mean values, yeah, okay? Different average salaries, yeah? So let's actually follow that up with a post hoc test. Let's actually try to figure out which one of those to go for, okay? Which one is actually causing the difference. Now, actually, what I'm going to do is I'm going to rerun this particular ANOVA. But there is another assumption that we need to be checking for, and it's the assumption of homogeneity of variances, yeah? We've already orchestrated this, that the data sets are normally distributed, yeah? But one thing that we haven't made sure is that the samples have been drawn from populations that have, I suppose, that are normal and that have the same variance, yeah, okay, which is got to do with their distribution. Now, earlier on when we had a look at the descriptives, I said that the variance for one of the groups was colossal. It was about 55,000, where the variance for the other was about 33,000. So maybe there is differences across the variances, in which case we violated the assumption of homogeneity of variances. And we'd probably have to think about doing some alternative test. So let's just actually run this test again. Compare means, Oneway ANOVA. This time let's go for options. And let's just ask for the homogeneity of variances results. Okay, let's hit continue. Let's hit OK. And what we get is we just get another table out here. This is the Levine statistic that's testing to see whether any of the variances are different. The null hypothesis for this particular test is that the variances of all three groups are equal. The alternative is that at least one possible pairing of them are not equal. And once again, you can see that the significance, let's actually see what the exact significance is here. If I just hover over this here. It's 6.7 by 10 to the minus 22, which is, once again, effectively 0. It's 0.00000000, so on, 67892. So there's evidence to suggest that we should reject the null hypothesis here, yeah? In which case, we're assuming that the variances are not the same, okay? Just keep that in mind now, yeah? Now, that's a violation of one of the assumptions associated with ANOVA. But let's just continue on, and now let's actually just follow up this particular ANOVA with a post hoc test. We know that we've violated the assumption of homogeneity of variances, yeah? Okay, so let's just read everything else with caution. We know that the result of the ANOVA is telling us that at least one of the pairings of our groups are significantly different, which means that somebody's salary is different, okay? But whose could it be? So let's go to analyze. Let's rerun this again. Compare means, Oneway ANOVA. But let's now have a look, okay? Let's look at some post hoc tests. Okay, so let's look at post hoc tests. Some of the recommended tests in relation to post hoc would be maybe Tukey's B or Tukey, or maybe LSD. Yeah, this particular test is probably one of the more recommended tests based on the literature. Now, we know that equal variances have not been assumed. Okay, so what I'm just going to choose is I'm just going to choose. Let's say there's 4 different versions of this particular test test that we can actually choose. But I'm just going to pick Dunnett C here, yeah, and let the significance level be 0.05, and I'm just going to hit continue here. Okay, and I'm going to rerun the test. You can actually see that what we get out here is we get, let's just see here. Okay, we have our homogeneities tests output, which we've already interpreted. We have the significance level here. Okay, and what we have here is, okay, the mean difference is significant at the 0.05 level. Okay, so what we have here in this particular output is our multiple comparisons. Okay, where we've compared clerical officers against custodials, clerical officers against managers, custodials against clerical officers, custodials against managers, managers against clericals, and managers against custodials. Yeah, okay. And you can actually sort of see here that we have stars on all of these differences. Okay, and what that's telling us here is that if there's a star, it means that the mean difference is significant at the 0.05 level. Okay, in other words, that there is a significant difference between clerical officers and custodials. Okay, there's a significant difference between them. Yeah, and there is a significant difference between the average earnings of clerical officers and managers. Yeah, custodials and managers, and so on and so forth. Okay, we actually just have a look at this here. Did I rerun this with the right variable? I think I did. Yes, I did. Yeah. Okay. So actually, there's differences right across all of our groups. Now, if we do this from a graphs perspective, graphs, legacy dialogues, histograms, get rid of current salary. I'm going to put in this normalized one. Okay, and let's have a look at the histograms for this. You can actually sort of see here that this one is the managers is this curve isn't overlapped with any of the other curves. Now, why that found that there's a difference between these guys, clerical officers, and these custodials, considering that the custodial distribution is contained within the clerical officers, I'm not too sure why that happened. Let me just rerun the test again. Analyze, compare means, Oneway ANOVA. Yeah, it's color salary normal. That's good. Posthoc. Let's try some other posthoc here. Let's just try Taffy's. And let's just hit continue. Okay. And our options, homogeneity is good. Let's continue on this. Let's hit OK. So let's rerun this again. And yeah, all of these are identifying the differences across the groups. Okay. So obviously the sample size is an important thing with respect to whether there's evidence to suggest that there's a difference. And the sample size for the managers is about 84, where the custodials, I think, is 27, and the clerical officers is 300 of them. So clerical and managers, there is differences there between them and so on. Okay. So once again, guys, this was Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland. And I hope this video detailing or how to undertake a Oneway ANOVA in SPSS was somewhat helpful. Okay, guys, so I hope to see you soon.